Type a question into an AI chatbot and the answer appears in seconds. The interface is clean, instant, and creates the feeling that you are interacting with weightless software living somewhere in the ether. But behind that simple text box is a massive physical operation. Answering a single prompt activates a sprawling network of specialized chips and servers that run relentlessly. Supporting that physical reality requires the electricity of an entire town to keep those servers processing information around the clock. A single large AI data center can demand over 100 megawatts of power to operate. To put that in perspective, 100 megawatts is roughly equivalent to the electricity consumed by 100,000 average American homes. Building one of these massive computing facilities is relatively quick. A tech company can usually complete a data center in just 2 to 3 years. Delivering that much electricity requires major transmission lines, which often take a decade or more to permit, plan, and construct. Utilities are forced to design and fund billion-dollar grid upgrades right now, long before the data centers are even finished. That timeline collision leaves a highly contested question: who is actually going to foot the bill? Computing at this scale turns almost all of its incoming electricity directly into heat. Power flows into the servers, and then even more power is required to pump water through industrial cooling equipment just to keep the processors from melting down. Follow the wires back and you reach the local substations. These facilities often have to be completely overhauled to step down concentrated, high-voltage electricity for the campus. Individual AI chips are becoming more energy efficient per task, but because the volume of computation is expanding so quickly, absolute energy consumption is still rising. These systems do not take breaks. They constantly train models and answer queries, turning a traditional grid, which normally peaks in the morning and evening, into a system that must sustain a relentless, heavy industrial draw 24 hours a day. This demand isn't spread evenly across the country. Data centers cluster in specific regions, meaning a manageable national trend quickly becomes an overwhelming local crisis for specific utility companies. In 2022, Georgia's state utility forecast needing only 400 megawatts of new power over 7 years. Just 1 year later, amid a rush of data center construction, that forecast exploded. They suddenly needed up to 8,500 megawatts of new generation. When tech developers make these massive speculative requests, utilities have to start building expensive physical infrastructure today to meet the expected demand years in the future. If a tech company cancels their project or uses far less power than they originally promised, the new power plants and substations still have to be paid for. Without strict protections, ordinary ratepayers get stuck paying off multi-billion-dollar debts for infrastructure they never needed. State governments and utility regulators are now stepping in to ensure that households don't end up subsidizing the expansion of the world's most valuable companies. Regulators in Ohio and Virginia are drawing a hard line. They are implementing tariffs that require data centers to pay for at least 85% of their contracted capacity, regardless of whether they actually end up using that much electricity. Georgia is enforcing similar rules, demanding longer contracts and strict financial backstops to legally bind developers to the massive energy promises they make. These measures prevent developers from reserving massive grid capacity for free. If they want a utility to plan for the power needs of a city, they must put down the financial collateral to back it up. At the federal level, regulators are leaning on an established rule for grid economics: the beneficiary pays. Under this framework, technology companies must cover the full cost of any dedicated infrastructure. If a new substation is built solely to feed a specific server farm, the developer receives the bill. The public only shares the cost of a project, like a major regional transmission line, actually improves reliability and reduces congestion for the broader community. Every time you type a prompt into an AI chatbot, it feels like a lightweight digital interaction, but you are actively engaging an industrial machine of cooling pipes, high-voltage lines, and massive power plants. The AI build-out is moving faster than the grid can follow, turning the technology race into a struggle over America's physical electricity supply. The outcome will decide what we build next and who pays the utility bill.